Previously, we talked about adding and subtracting polynomials. Today, we're going to jump into the multiplying aspect. And specifically, all we're going to do today is multiply polynomials by monomials. And that's basically a fancy word for just we're going to do a lot of distribution. Now, we have rules for multiplying exponents. We take, and as long as the bases are the same, we add the powers. So what I think we'll do first is we'll start by distributing the 6y into this term. So I multiply the constants by the constants, so that's 24. And then this has power of 1 on that y, so I add 1 and 2 and get 3. Minus 54. Each variable has a power of 1, so that's y squared. And minus 42y. None of these have like terms. They all have the same variables, but none of their exponents are the same, so that's completely simplified. So in this example, we're going to take and multiply two terms, one of which is a trinomial, one of which is a binomial, and we'll go through and get our first term of 6t squared minus 12t minus 45 plus 30t squared plus 12t. Now I need to look for like terms, so I see I have a t squared here and a t squared here. I take the coefficients and add them, which is 36. I keep the variable and the exponent the same. Now I notice I have a negative 12t and a positive 12t, which add to 0, and my constant term of negative 45 is left, and that's all I've got. In our next example, we notice we have variables on both sides of the equation. So we're actually going to be solving in this case, but we have to do our multiplications first. So I have a 12b plus b squared minus 7 equals 2b minus 4b plus b squared. Typically, we want to get all the variables to one side of an equation, so I'll subtract b squared from both sides, and in doing so, you'll notice that the b squared terms go away, which is good because we didn't really know how to deal with those anyways. So that leaves me with common terms here, or like terms, of negative 2b when I add those up, and 12b minus 7. I will subtract 12b from both sides, giving me a negative 7 equals negative 14b, and divide negative 14 to both sides. Get positive 1/2 is equal to b. Very similar problem here, a lot more multiplying to do. Distribute, distribute, and distribute. So in this case I have x squared plus 2x plus 2x squared minus 6x plus 7 equaling 3x squared minus 15x minus 12. I see I can combine like terms over here. So this is a 1x squared plus 2x squared is 3x squared minus 4x plus 7 equals 3x squared minus 15x minus 12. I'm going to get all the x's to one side of the equation. I'll start by subtracting 3x squared to both sides. And you'll notice the 3x squareds disappear because that's 0. Then I have negative 4x plus 7 equals negative 15x minus 12. Add 15x to both sides. subtract 7 to both sides, we end up with 11x equals negative 19. Divide by 11 to both sides, and x equals negative 19 over 11. So now we've got a word problem or an application problem, and we read through and find out we have peppers selling for 39 cents each, potatoes selling for 29 cents each, spending a total of $3.88 on vegetables, and there are 4 more potatoes than peppers. So I'm going to go potatoes is PO and peppers is PE. And I'm going to make a comparison between potatoes and peppers. So there are 4 more potatoes than peppers. So if I go peppers plus 4, that equals potatoes. And then I can use these cost equations to say that I have 39 cents, and I'm going to use pennies, I think. So the peppers, 39 cents each, plus the potatoes, which are 29 cents each, should equal 3.88. So this is a system of equations where I can take and use a substitution, which I think I'll do, for the potatoes. So I have 39 times the peppers plus 29, and here's where I make my substitution. Peppers plus 4 is equal to 388, and here's where the multiplication comes in. I distribute, so I have 39 times the peppers plus 29 times the peppers, 116 equals 388. Subtract 116 from both sides and add like terms on this side. So I have 68 peppers is equal to 272. Going to divide both sides by 68, which means I have 4 peppers. If I have 4 peppers, then I have a total of 8 potatoes, since I have 4 more potatoes than peppers. So in this next example, it looks like we have a consecutive integer problem. It says, what is the product of twice the integer added to 3 times the next consecutive integer? So we're going to take and call the first integer x first. And if it's a consecutive integer, that's x plus 1. And we want a product of twice the integer added to 3 times the next consecutive integer. So I distribute this through. It's 2x plus 3x plus 3. And all we're really asked to do is find an expression. So in this case, I had like terms. 2x plus 3x is 5x plus 3, and I have none. That's all we've got. Here are your problems to solve. Make sure you write your lesson summary, and we'll talk about it tomorrow.